Okay guys, I thought I'd go through practice task 1, the road trip, which is going to be vaguely familiar from one of the other tasks that we had a look at. So let's take a look. Okay, so practice task 1, Xavier, Yelda, Zed and Alfred are going on a road trip. Okay, so you'll notice that there is 1, 2, 3, 4 different people. So if we remember our skills that we need to use, there's finding the shortest route, there is finding a maximum tree span, there's a minimum tree span, and also traversability. It makes sense that there's 4 different people with 4 different expectations. So you can see Xavier is eager to get from Fairley to Invercargill as soon as possible to ensure they are in time for the All Blacks test on Friday night. So the key word there is as soon as possible. So this is your shortest route question. So if nothing else, you should think, got to find the shortest route between Fairley and Invercargill. Zed is currently studying networks and he wants to create a spanning tree which could connect every town exactly once using the roads with as many rest areas as possible. So as many is the key, that it's the max tree span. All right. The other thing that can be a little bit tricky is getting confused with traversability, that it's connecting every town once. Okay, using the roads and only using the roads. Alfred is in the same class and wants to create a spanning tree which could connect every town exactly once using the shortest road length possible. Okay, so that's your minimum tree span. Both Zed and Alfred want to include as many roads from their tree span as possible in their final route. Yelda is into sightseeing, so she would like to visit every town without driving any roads more than once. Is this possible? Explain your answer. So it's the one that's left, but we should be able to pick that. It's traversability. Okay, this task requires you to find the optimal path for each passenger and then design a network that meets as many of the requirements as possible. Present your optimum network, justify your decisions, and make a recommendation for the group. Okay, so here is our network and also the distances. It's a little bit tricky with these distances they give you. It's slightly different from the table that we've used before. It actually doubles up the information. So get the laser pointer. So this square here means from Fairley to Geraldine, and this square here means from Geraldine to Fairley. Now they're obviously the same distances, so you can see that's repeated Timaru to Geraldine and Geraldine to Timaru and so on. So it's a bit of a trick, this one, that you don't actually need all of these values. So you only need to use half of them. Now it wouldn't matter if you use the top half or the bottom half, but you just only need to include one. So I'm going to use a green pen. So if we start constructing our network, so the first thing we've got Geraldine to Fairley. Geraldine to Fairley is 46. We can cross that out. Next one, Geraldine to Timaru is 35. And Fairley to Timaru is 63. And you can go on building that up all the way. So if we skip through that to a completed network, and the next stage is to find the shortest path. Actually, I've forgotten what it is. Shortest path from Fairley to Invercargill. always best to go back and check. So put a highlighter. Yeah, so we want to go fairly to Invercargill. Try that again. Fairly and Invercargill. And so starting off with Fairly. Now we're going to have to move it over here. From Fairly, I can either go to from Fairly, I can either go to Timaru, or I can go to Wanaka. If it's Wanaka, it's 243. If it's Timaru, it's 63. Alright, from Timaru, I've only got one choice because I'm not going to go back towards Geraldine. I can go to Oamaru, which is adding another 84. So 3 plus 84. Gives me 147. Now from Wanaka, I've got a choice. I can go to Oamaru. However, that will be 231 plus 243, which will give me 474. Now I'm not going to continue that branch because I have this other Oamaru that is 147. So the other option from Wanaka is to go to Cromwell, and Cromwell 243 plus 55, which is 298. So then from Cromwell, I can go to Dunedin, which adds 298 plus 221, which gives me 519. Or I can go to Queenstown, which will be 298 plus 62, which gives me 360. Now on this other branch, I can Oamaru. I could go back to Wanaka, but I'm going to run into the same problem that I did before, so I'm not going to bother doing that. So we could go to Dunedin and add another 115. So that's 147 plus 115 gives me 262, which means that Dunedin option is no longer a problem. So we've still got these two branches coming from Queenstown and Dunedin. I'm not going to go back to Cromwell from Dunedin, so I could go to Invercargill directly, or I could go to Gore. And yes, so I could go to Gore, or from Queenstown, I could go to Invercargill directly, or Gore. So from Dunedin, if I want to go to Invercargill directly, it's 262 plus 217, which gives me 479. And if I go from Dunedin to Gore, 262 plus 151, which gives me 413. And if I go from Queenstown, so that'll be 360 plus 187, which equals 547. So that's no good because I've got the 479. And if I go from Gore to Queenstown to Gore, I have to add a 169. So 360 plus 169 equals 529, which again is no good because I've got the 413. So the last option is go to Gore to Invercargill, which I have to add 66 to. So it would be 413 plus 66, which gives me 479, which is an interesting result because we ended up with two answers of 479. So in this case, you can choose either route. They're going Fairlie, Timaru, Oamaru, Dunedin, directly to Invercargill, or it wouldn't matter if you chose to go through Gore if you needed to. Now that's an important thing when it comes to deciding the optimum, is that it might be more scenic value to go over one of those options more than the other. So you can kind of appease one of the other people by making a selection that doesn't matter to Xavier, who's looking for the shortest distance.